Now next, let's see the other properties involved with parallelogram. Now that we have connected between parallelity and equality of opposite sides in a quadrilateral reducing to a parallelogram, let's connect with angles. What are the properties related to angles in a parallelogram? Angle properties. In a parallelogram. So let's see how the angle properties are defined in a parallelogram. So let's take a parallelogram ABCD. So here I have a parallelogram A, B, C, D. So A, B, C, D is a parallelogram in which opposite sides are parallel and of course equal. Now this is angle A, this is angle B, this is angle C, this is angle D. Now here A and C are called opposite angles, B and D are called opposite angles. Angle A, angle C, angle B and angle D are called pair of opposite angles, are referred as pair of opposite angles. So let's see in today's session about the property which connects with opposite angles in a parallelogram. For a parallelogram ABCD, the property says that opposite angles of a parallelogram are always equal. That is, this equals this and this equals this. So the property here says that opposite angles in a parallelogram are always equal. Opposite angles in a parallelogram are always equal. Is how we conclude the property. That is, in this case, angle A must be equal to angle C and angle B opposite to that is angle D must be equal if ABCD is a parallelogram. For a parallelogram ABCD, opposite angles must be equal is how we understand the property connecting the opposite angles. Opposite angles in a parallelogram are always equal. Now let's see the converse of the previous session. Today's session is about the converse connected with the angle properties in a parallelogram. The converse. So what is the converse of the angle property? Let's revisit the angle property as discussed in the previous session. In a parallelogram ABCD, if we have defined that the opposite angles are equal. Now comes the question, if in a quadrilateral the opposite angles are equal, will that be a parallelogram? This is how we understand the converse. So imagine I take a quadrilateral ABCD, a quadrilateral ABCD, which is not a parallelogram yet, I say my opposite angles, angle A and angle C, are equal, and my other set of opposite angles are equal, then this quadrilateral must form a parallelogram, is how the property defines. If the opposite angles in the quadrilateral ABCD are equal, then the four-sided closed figure formed, the quadrilateral thus formed with opposite angles being equal, must be a parallelogram, is how we understand the converse of the angle properties. So this equals this and this equals this. So the property says if opposite angles are equal in a quadrilateral, then the quadrilateral will form a parallelogram, is how I understand the property connecting the parallelogram with opposite angles. So if opposite angles are equal in a quadrilateral, then the quadrilateral will form a parallelogram. Therefore, for quadrilateral ABCD, which we have out here, if angle A equals angle C and angle B equals angle D, that is opposite angles are equal, then ABCD is a parallelogram. That is, ABCD will automatically have its opposite sides being parallel. With opposite angles equal, the quadrilateral shifts to be a parallelogram, is how we understand the learning outcome of the converse of angle properties in a parallelogram.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.